This is our Polymers Application Material Selection Report by Team 2, including Preston Badiac, Adam Elsersy, and Jackson Tarpein. Alright, before we go any further in the presentation, we'd like to explain the design problem. This project focused on the innovation of 4 components of a vehicle: the fan shroud, cowl tray, splash panels, and mirror housing. The objective was to find substitute polymers and verify material properties through material testing.
The part I'm going to talk about today is the fan shroud. The material we picked was glass fiber reinforced polypropylene, PPGF30. We looked at 5 categories with that. We looked at heat resistance, long-term thermal stability, stiffness without deflection, and dimensional stability and efficiency. We looked at those and fulfilled 3 requirements: continued service temp up to 230 degrees Fahrenheit and 110 degrees Celsius. We looked at stiffness, and then we also looked at lightweight. Specifically, with the continued service temperature, we looked at heat deflection with the test at ATSM D648. We then looked at relative thermal index with the UL746B. Then with the stiffness, we looked at flexural modulus, tensile modulus, and coefficient of linear thermal expansion with the test ASTM D790, D638, E831. And with the lightweight requirement, we looked at the density with D792. Why does that matter? That matters because we specifically looked at these tests against other commonly used polymers for the same manufacturing processes, such as nylon 6,6. And this PPGF30 outperformed that in every category.
The next part we're going to cover are the splash guards. So the material we picked for the splash guards to be made out of was a high-density polyethylene. There were 3 main requirements for the splash guards. That was resisting gravel, debris, and ice, and impact from those objects, maintaining its shape under stress and vibration, and moderate thermal expansion properties. So for the resistance to impact from gravel, debris, and ice, we chose impact resistance testing and durability. For the impact resistance, we used chip resistance. That test was SAE J400. And for the durability, we chose resistance of the material to chemicals. That was ASTM D543. We found that high-density polyethylene outperformed common materials used to manufacture splash guards, such as low-density polyethylene. The next requirement we needed to meet was maintaining its shape under stress and vibration. So we once again used toughness, vibration dampening, and impact resistance for this. The vibration dampening test that we used was static and kinetic coefficients of friction. That was ASTM D1894. And then for toughness, we used the ultimate elongation test. That was ASTM D638. And then for our last requirement, which was moderate thermal resistance, we used a heat resistance test. That test was a coefficient of linear thermal expansion. That was ASTM D696. For all of these categories and testing reasons, we decided that HDPE was the best option compared to other traditional materials used to manufacture splash guards, such as low-density polyethylene and polypropylene.
The next part I'm going to talk about is the cowl tray. The material chosen for that part was the UV-stabilized polypropylene copolymer. We had 3 testing requirements for that part, and we chose 3 categories with that. For the weather resistance requirement, we looked into the durability of the part. We looked into the accelerated exterior weathering. With that, we used the testing standard from SAE J1960. And we compared that to other commonly used materials for this application, such as ABS. And we found that our copolymer outperformed ABS in this situation. For our next requirement, which is impact resistance, we chose toughness, and we dove into that with an impact resistance test with the testing standard from SAE J1740. And we found that our polypropylene copolymer outperformed polycarbonate and other traditional materials for that application. And then for our last standard, which was surface finish, we looked into appearance. We chose specular gloss, and color difference. We used 2 testing standards, which was ASTM D523 and D2244. And we found that in this case, our polypropylene copolymer met the requirements for the surface finish better than other materials such as polycarbonate. In summary, our UV stabilized polypropylene copolymer outperformed across these categories other materials for the Caltray.
The next part is mirror housing. For the mirror housing, we selected the material polycarbonate acrylonitrile butadiene styrene, which is a polycarbonate blend. Our requirements were a Class A finish, a high stiffness, and a strong impact resistance. To test our Class A finish, we put the PCABS blend through a molded-in color test and a color test itself. For the molded-in color /UV, we used a UV moisture test, which is under the code SAEJ1960. And for our color test, we used a color difference test, which is under the code ASTM D2244. This material tests better than other traditional materials used for mirror housing, such as polypropylene and traditional ABS. For our high stiffness, we used a structural stiffness category, which was put through a vibration dampening test, which was a finite elemental analysis. And for our strong impact resistance, we used a impact resistance and impact strength category test, which is for our impact resistance, we used a falling dart, which is under the code SAEJ2561. And for our impact strength, we used an IZOD impact strength test under the code ASTM D256. Through these tests, we concluded that polycarbonate acrylonitrile butadiene styrene tested better than traditional materials such as polypropylene and traditional ABS, and we concluded that this would be a better material to use in the automotive industry.
There were a lot of lessons learned from the research of this project, but one of the biggest ones was material selection and how critical it is to performance. Choosing the correct polymer for an automotive part can be the difference between dangerous recalls and long-lasting life. The balance between cost and performance was also a really important thing that we learned about. If cost wasn't a factor, every company would make as many parts as they can out of the fanciest carbon fiber or other polymers, but due to cost, that's just not realistic, and you have to take into account how much it's going to cost to manufacture a part out of a certain plastic or polymer. And lastly, environments that a part functions in and how much it matters. Characteristics like UV stability drastically affect how long a polymer will last in the sun. You have to consider during your design where and when your part might be exposed to UV and for how long. And other characteristics about degradation were also really important that we learned about. In conclusion, our project focused on the selection of optimal polymers for specific automotive parts to improve their heat resistance, strength, and durability. Those parts were the fan shroud, splash panels, Caltray, and mirror housings. We chose our polymers based off the properties needed to meet our specific requirements. Our selections critically affected reliability, efficiency, and sustainability in our parts. And finally, these are our references.